Hi, welcome to Habitat by Chef. I'm going to not use this remote. Habitat 101. So I'm going to tell you about Habitat today. So if you don't know who I am, I'm Joshua Timberman. I probably wrote cookbooks that you use for Chef that were rewritten by other people so that they're good. I'm a member of the Chef Board of Governance, which is part of our community guiding board. I've taught Chef, and I'm now on the Habitat core team, so I work full-time with Habitat and making it do cool things. And I probably overheard something you said and posted on Twitter. So this is the abstract that is on the ChefConf site. This is probably what you saw on the schedule. I'm kind of going to cover these, but really I have some goals for today that look more like this. I want you to understand why Habitat exists, if you don't already know. I want you to know what Habitat itself is, and I want you to be able to get started using it. Now, I don't have enough time to go into an in-depth tutorial about the various pieces and parts. Habitat is actually a really featureful and big software program, so there's a lot of things to know about it. It's application automation, and of course, for running any kind of applications, we have to have infrastructure. So why do we run infrastructure, right? Is it because it's fun? I mean, I think it's fun. I'm a systems administrator, so I have a lot of fun with running infrastructure and being frustrated with computers because then you have that challenge that you get to solve. But do we run infrastructure because the business requires it? We don't, of course. We need to run applications, right? Well, we don't actually need to run applications. We want to ship our ideas, right? We want to get those ideas out there. Of course, those ideas are usually wrapped up in some kind of application that provides customer value in some way. So why do we have these applications? Is it because the business requires it? Software's eating the world, right? Everybody has applications. They're the foundation of any nutritious breakfast, like breakfast tacos. My massage therapist has a website and application that she has to run so that people can schedule massages with her. Etsy and Facebook and Google and your company all have applications. So that's great. We have applications. But how do we run them? Everyone runs their applications a little different. Some people run their applications using Java as the language that it's written in and then run it in the JVM. Some people write .NET applications and do it that way on Windows. And we can argue all day about which one is better, about which way to paint which color to paint the bike shed of how we run our applications. At the end of the day, we end up with industry best practices that look like this. I'm glad Hadoop is in there. But these days, it's all about containers, right? And Adam talked about using Docker and having that container, that production difficulty, and it gets more difficult as you go closer to production, and then you have learning cliff, and then you're like, okay, I've mastered Docker, and then all of a sudden you're like ready to go to prod, and you're like, oh yeah, we have all these other things we have to do. And containers are our best practice, but not everybody's running containers. Some of us run our servers on bare metal. You can actually buy this T-shirt, the artist. The link is up there, and I'll make the slides available later. But I'm definitely going to get that T-shirt because that's amazing. But at the end of the day, most of the time, what we have when it comes to running our applications and running our infrastructure is the configuration management trifecta, right? You have a package, you have a config file, or 17 config files, and then you have a service, right? Your application runs as a daemonized service listening on port 80 or port 8000 or whatever it is, and then people can use it. And we solved this problem with Chef by installing the package for your application and then having a separate config template that lives in a cookbook instead of your application repository. And then you manage the service of the application, which is going to be systemd or runit or all that. But Chef abstracts that away for you, and we totally solve that problem, right? I mean, obviously not, because I'm totally leading you on. We have operating system considerations. All right, this is another area of bike shedding and arguing on the internet. Do we use Red Hat? Do we use Debian? Are we just going to drop off a jar file because our application is Java? Are we just going to use tar-gzs because we're on Gentoo or Slackware, or just because we think that's the best way to package things? When we need to run our service, is it going to be init? Is it going to be systemd? Are we going to use upstart? It depends on which distribution we're using, right? Like we've tied our infrastructure to these operating systems that have all these preconceived notions about how they think that people are going to want to run their applications. But they don't know your application. You know your application, and you're like, putting it in runit is ridiculous. Why would you do that? Or I don't like systemd because they have taken over the entire operating system. I don't want to do that either. And aside from that, where do you put your config files? Do you put them in /etc? Do you put them in the applications directory? Are those config files .conf, like standard Unix config files that are not standard at all? Are they YAML, where white space is pretty cool? Or JSON, where you have no comments? So, we have all these different standards of the way that we all run our applications, right? Because everybody's infrastructures all look the same? No. But the wonderful thing about standards is that none of them matter. Like I said, what the distributions are doing, the way that they think that you're going to run your app, they have no idea because they don't know your app. And the applications themselves don't care. They just need to be able to run somewhere. And what happens is, at the end of the day, most organizations write these various layers between the application and the operating system. You've got things like Chef and console and etcd, and you have glue scripts that have been hobbled together over the various years. And then we also have language runtimes that ignore what the operating system is doing entirely, right? You have, the languages are going to install in user local, or they're going to install in var opt, or some weird location that you never know what's going to happen with them, because you don't necessarily know what their assumptions were about it, and it does. You just have to make your application work with it. So the way that we solve this, of course, is with Habitat. And what Habitat is, it's application automation that enables modern application teams to build, deploy, and run any application in any environment, from traditional data centers to containerized microservices. That sounds like an awful lot of buzzwords. So let's break that down a little bit and put it into terms that are maybe a little more meaningful. We're talking about the application, so we treat the applications as the first-class citizen. So the application comes first. Its concerns are what we want to worry about. We don't want to worry about the distribution and how it's packaged things and all that. So we put the application first. Then we defer the decisions to runtime. Habitat itself exposes an interface that allows you to change the behavior and change the configuration of your applications at the runtime and handle reconfiguration dynamically. So what that means is that you can set environment variables at runtime when you start the application to affect its behavior, rather than having to lay out an entire file system full of config files before you can actually start it. Habitat is automation that travels with the application. You package everything that your application needs to run with Habitat. You package up the application code. You package up any of the runtime dependencies. If you're using like a Rails app, you would bundle your dependencies into the package, and you have all your configuration lives in the applications repository. Your startup scripts, all that stays with the application in a package. And the way that we do these packages, we build them in a clean room called a studio. So the studio is just a chrooted environment that doesn't have anything in it, so there's nothing from a distribution that's going to interfere with the way that you build your application. So if you have a Java application, it's completely isolated away from any distribution-specific versions of the underlying libraries. So you need to have all of your dependencies in there, and you package those as Habitat as well. So we'll get to that here pretty soon. So when we enter a studio, we use the hab command, and it has a studio subcommand, and it gives us some output. It says it's creating a studio directory, and then it imports the delivery secret origin key, and that is because that's called delivery. It could be called Core, it could be called Acme Corp, it could be called J Timberman. Well, you couldn't use J Timberman because that's my key, so you make your own. And then it imports the origin secret key, and then it enters the studio. And now I'm in a 64-bit Linux environment. That's what Habitat runs on currently. And in here, I can perform the build of my package. And I can exit the studio and then upload the package and do things with it from there. And I can go back into the studio and have a repeatable build. So if I need to release a new version of the application, I go into the studio, I do a new build of the application, and it gives me the application artifact again for the new version. So Habitat itself is a packaging system. You build a packaged app of your application as an artifact, and then you install that wherever it needs to run. So let's look at the anatomy of a Habitat package. Every Habitat package has a fully qualified package identifier that consists of the origin. In this case, the origin is core. Then the package name. In this case, this is the Hab package. It could be Apache, it could be MySQL, it could be Redis, it could be whatever your cool application is named. And then you have a version. This version is going to be whatever the version of your app is, right? Like if I'm using Apache 2.2, then this would be 2.2. If I'm packaging up a dependency like Ruby and I wanted Ruby 2.3.0, that would be 2.3.0. And then the last part is the release. So every time you build an artifact with Habitat, the package gets a specific timestamp release, so that you can always use the latest one, or you can use a specific release of a package. Then the Habitat artifact itself uses the same kind of naming. This is the artifact for the Hab soup package. So it has the origin, the package name, the version, the release, and then also in this file it has the target, which is the architecture and the operating system that package is built for. And then we use a heart extension because we love you. So inside of a Habitat package, we extract those out to /hab/packages/ the origin name. So in this case, it's core, but it could be Acme or Microsoft or Chef or whoever packaged that thing. It would be that origin. And then the name of the package again, the version, the release. So that's a directory, and it has a bunch of files in it. And the files in here that are in all caps are the metadata files that Habitat created when the package was built. There's some others. I'm going to talk about some of them. So the other thing is that in this package, I have a bin directory with a Hab binary. Hab is a statically compiled binary, so it doesn't have any runtime libraries or anything else in there. But your application might have a lib directory or an include directory with headers, or if you're using dependencies like libpng or libxml, those packages have those directories because that's part of that software. But if you have like a Rails application that has a config directory and your lib directory and the vendor directory where you put your bundle, like all that stuff would be in this directory here. Some of the metadata files are related to the dependencies of the package. You have a build deps, which is the dependencies for building this package. So if I'm in a studio and I'm going to build the package, those are the ones that will be installed on the system in that true-rooted environment so that the package can actually get built. Sometimes you need things like make and GCC for build time, but you don't need them for runtime, right? So the runtime dependencies are in the deps file. And that is just the things that that package needs to run. Now, this is an excerpt from the build deps for the Hab package. Like I said, it's statically compiled, and we use the Musil C library so that it's smaller than using glibc. But these are all build dependencies. The Hab package doesn't have any deps. There isn't a deps file because it has no runtime dependencies. Now, if I had a package that had a runtime dependency, like a Java app would depend on a JDK, so I'd have a JDK package, and it would be listed in here with core/openjdk/1.8. Whatever / and then a release. So all of these dependencies are all the specific release of each one of those packages. So this way you know that when you install this package, it has these dependencies listed with these specific releases. So you can always get the same thing every time when you install it. When we think about the principles of immutable infrastructures, where you've got you don't want things to change, you can verify that things haven't changed because we know that all these are the same dependencies. We also have a tdeps file and a build tdeps file. That's for transitive dependencies. So those are things that a dependency that I have depends on, right? So I might need OpenSSL, and OpenSSL needs zlib, but I don't need zlib directly. I know I'm just going to get it with OpenSSL. We also have a file called files. And this is a list of all of the files in the package when the package was built. And we have the Blake2b checksum for, it's a hash of the content for every file. Now the slide isn't wide enough because those checksums are really long, but just imagine that those are all one line each. And then this files file is signed so that you know that it hasn't been tampered with. So you can check this file on disk and verify that everything in here is exactly what you needed. For certain organizations that have compliance requirements or security requirements that say that they need to, you need to verify everything, that is easy to do with this. Then we have an ident file, and this is the fully qualified identifier for the package. And then one of the other metadata files that is important is the manifest. The manifest is is like a markdown file that we can put on the Habitat web UI and display it nicely. So you can see manifest down there, kind of just below the middle. That manifest is the markdown file that would be the same thing as if I looked at it on disk, but it'd just be in markdown. Every package that you have that has binaries that you want to be able to run, you define that where the binaries directory is going to be when the package is built. Usually it's bin, and it will automatically create a path file that when Habitat runs, it can load those for the application. All the dependencies paths files are added to the path when a user logs in. So you'll have access to all those locations because all the Habitat packages are all installed in /hab. So we don't care if you have /user bin bash on your system because we have a bash package. So if you need bash for Habitat, you use Habitat's bash, and then you know that it's there. And it would be added to your path. We also have an exposes file. So a lot of applications need to listen on some port somewhere. So you define what ports you want in your plan. And then this exposes file gets written out with those ports. There's some other files that are useful if you're building like C software that has C flags or LD run path and LD flags. So after you've built your package in your studio, you have the heart file. Then you upload that package or your packages to the depot. The depot. Habitat also has built-in service discovery that is over a gossip protocol. We use Swim for that, and every system that starts up for running your application, like you need a database, you need your app server, you might have a proxy, load balancer in front of it, those all start up and they can discover each other through this gossip layer. And if you listen to Adam's keynote, he talked about how we wrote our own gossip layer. We used to use etcd. And that is based on the Swim protocol. So when we start up a service, like the core Redis package, we can see that there's some information about the gossip listener and the distributor. And we also have the supervisor is running on this IP address. So when we start other services or other applications and services that need to use this, we can tell it to talk to that IP, and then that will join the gossip ring. The HAB supervisor also has a configuration service. So that allows us to ask questions through a RESTful API. It runs on port 9631, and we can hit /config, and it will dump out the Habitat TOML configuration about that particular service. There's a couple other endpoints that we can get to as well. These are all documented in the Habitat documentation. Because we work with a lot of companies that have security and compliance concerns, and we want to be responsible, grown-up operators, we want to have encryption and signing so that we can have verifiable packages and content that we know has not been tampered with. We use libsodium and Blake2B for signing artifacts and hashing file contents for their integrity. And then for running the depot and the website, those both use HTTPS, and we support HTTPS. You can, if you wanted to run your own depot, then you'd be able to do that with HTTPS and your own wildcard cert or whatever. The signed packages. One of the cool things about the heart artifact files, the Habitat artifact, is that you can just use head to read the header that has the signing information. So in this section, I'm going to cover a number of Habitat basics. I'm going to go to my terminal here in a moment, and I'm going to run some commands. And I'm not going to be able to go super in depth because of time constraints, but I want to give everybody a feel for what it's like what the various parts of Habitat are and what it's like to work with it. The website, habitat.sh, has tutorials and a demo that you can work through on your own, and then there's a download link. You can download the binary and start using it right away. So I'm going to go to my terminal. So Habitat is a Git repository on GitHub, and I have it here. Well, I'm going to go back over here. So for example purposes, we have a Ruby on Rails application. Now, I know not everybody runs Ruby on Rails, and that's fine. Whatever your application you run, you'd go to whatever its repository is, and then you would, if you're going to start using Habitat, you'd create a Habitat directory, because that's the default location that Habitat's going to look for when it's working with your packet, or when it's working with your application to package it. And then we have a plan.sh. So the plan.sh is a bash shell script. It's all Apache open source, Apache licensed, open sourced. And when we write a plan, it's a shell script that is going to be loaded up by a build script that just sources it. So the build script sources my plan.sh, and it's going to pick up a bunch of variables and some callback functions to tell it how it's supposed to build this package. So all these package underscore variables are all the things that inform the build script about various parts of it so that it can build this application. So the package name is Ruby Rails sample. So remember we saw /core/hab, we would see core/ruby-rails-sample. We have the package version is 0.0.1. I could change that and make it a 0.0.2. I can make it a 0.2.2, whatever my versioning scheme for my application is going to be, I can change that. I was working with this in Chef Delivery, which is now the workflow part of Chef Automate. So I have the package origin as delivery. The maintainer is the Habitat maintainers. This application itself is MIT licensed. I forked it from a sample that Heroku uses. I download the source from GitHub, and I get I have the package SHASM. I know that file is going to have that SHASM when it downloads. I define all my dependencies as a bash array. So it needs bundler and CA certs, and it also needs, I don't know why you need Node to run a Rails app, but like I'm not going to judge, it's cool. This application uses Postgres, so it needs Postgres in order to have the Postgres client libraries. And of course, it needs Ruby. The build depths, it needs core utils, GCC, and make. Those won't be installed on the resulting container or resulting, sorry, they won't be in the dependencies when I install it on a container or a VM or something. And we have the lib directories, the include directories, and we expose port 3000. Now these callbacks, or these functions are callbacks that are, they override functions that are defined in the build script. So the build script has a prepare function that does a thing. It has a do build function that does something, depending on what the software is. But I'm going to override those and make it do what I need for my application in order to be built. So I'm setting some local variables. I export some environment variables. I handle Nokogiri. Note that we're using the system libraries. This would use the HAB system libraries. Has anybody compiled Nokogiri for a Rails app? Hands up. Yeah, so we solved this problem for you. You're welcome. This sets the bundle config. Like, this is all the stuff that I need in order to have this Rails app be something that I can deploy. We bundle install into the vendor bundle directory, and so when I run this on my system, when I go into a studio and I do a build, it's going to load this plan and get to work. The do install is similar to like if you have a if you know like GNU C programs, you do like configure make install. That would be the do build, and then the do install would be make install, right? So that's you know those functions are broken up like that. This is how we're doing the install for this package. So this may not finish before I'm out of time. So I just wanted to talk about some of the output here real quick. So remember I said we enter a studio to do our build. And I'm entering the studio from the Ruby Rails sample application repository. Then when I go in there, like we saw on that slide, I run build. And this is, build is a script that loads the src habitat plan.sh. It looks in habitat for the plan.sh file. You can also specify that if you want. And now it has loaded it. So before we have nothing here, before this colon, but now we have Ruby Rails sample because it's loaded that package name and it's going to continue doing the rest of the build steps. It automatically went and installed core utils and GCC and make and their dependencies, right? So we've got some libmpc and so on. So it installed all the things that it needs to build the software, and it sets some variables, and here's where it's running bundler. So we're building the package. It's taking a little while because bundle install can take some time. Some of the other things that you work with in Habitat, when you're going to run your application, you need to run it in some way, right? So we have the notion of hooks, and you have we have the run script, which it does whatever you need to do to initialize and run your application. So in this case, we need to set some environment variables so that the application knows where the gem home is, or the gem path is, what the path where commands are going to be located are, what the Rails environment is, and then at the end here, we actually start the application. And the run script should run something that runs in the foreground because it's going to supervise it and handle it. So you don't want something in the background because then it'll think it'll have lost what it thought it was supervising. So at the end here, I love it when a plan.sh comes together. At the end here, we have where's the line? we have a tarball that was created, and then it gets compressed with xz. So we have a tar.xz, and then we sign it and create the heart file. So this is the artifact that gets created. So when Habitat runs, it creates this habcache artifacts directory, and it then writes any artifacts that it builds out to the heart files there. We also create a /src/results because this is a clean room environment. This is actually running in a Docker container so that it's completely isolated, and also because I can't run Linux directly on OS X, right? Because you have to have a VM of some sort running. So I just used the native Docker for OS X. So if I exit this, then try and go back in the studio, all this stuff in /hab is gone. But we have a results directory because the Ruby Rails sample, the application directory that I was in, when I did the hab studio enter, it bind mounts that directory as /src. So that's how I have all the Rails sample stuff. And then the results directory has my artifact as well. So when I exit, I still have access to it. We also have a last build.m, which is just a key values of information about the build that you can use inside Jenkins or Chef Automate or whatever your CI/CD system might be. You can use this elsewhere. Like if you needed to publish a list of package checksums on a website for your downloads, then you could get that out of this file. All right, so getting low on time, so I'm going to continue with the rest of the presentation. As soon as I figure out where my turn off mirroring is. Okay. So let's talk a little bit about Habitat and Chef workflows. So we love Chef recipes, and in order to use Habitat in Chef recipes, right now, like the main thing would be you'd want to get Habitat installed on the systems where you're going to run your applications that are packaged with Habitat. So we can use a remote file resource to download the core hab package, and then we can extract it using tail and xzcat and tar. Now this of course isn't convergent. It's idempotent because it will run that every time and it won't change anything because it's going to get the same version each time unless you change those attributes. But it shouldn't like run that every time, so you'd want to have like a guard in there. But for this, it's fine. This is just like a basic Chef recipe to get Habitat installed and then install the package with hab install. We do some of this in our build cookbook. So we have a build cookbook for using Habitat inside a Chef workflow if you're using Chef Automate. Now that build cookbook has a detailed README, so if you're using Chef Automate and you have workflow, which was called delivery 2 days ago, you'd use that build cookbook in your own build cookbook. You can depend on it and make sure you get it by updating the Burks file and the metadata in your build cookbook. We also have a Ruby client library for Habitat. And this is used in the build cookbook for a few things, like being able to get information about a package from the repository. So just a little bit of sample code. We can create a new instance of the Habitat client, and we can also point it at a different depot. So if we set up our own depot on localhost or on some internal system instead of using the public one, we can do that. And then we can show packages, and we also have the notion in the depot to promote packages, which puts them into a different view. So you could have like a production, a testing, a staging. With delivery or with Chef workflows, you'd have views that you'd promote through the various union, rehearsal, and delivered phases inside of that Chef workflow. It's available as a Ruby gem from rubygems.org, so you just use the new cookbook metadata feature where you can say a gem to install and it will handle it, or you can just put Chef Gem Habitat client in your recipe. We don't yet have Habitat package and Habitat service resources, but we'll have those soon so that we can have that hab install not be an execute block. That'd be pretty cool. And that's about it for the Chef workflow section. So I have a few, as we wrap up, I have a few frequently anticipated questions. So hopefully get ahead of some of the questions since we won't have a whole lot of time for that today. But the first one, does Habitat replace Chef? No, because you still have infrastructure you need to manage. You still have users that need permissions, and you need to set up your monitoring and logging and all that stuff for the operating system and for the infrastructure that your applications run on. Habitat supplements Chef by giving you a first-class, application-centric way to package and manage your applications. And then you can use that within Chef. How does Habitat work with containers? Because Docker, mushroom. Docker is a big buzzword lately. It's really easy to use and it's delightful for people, and they want to be able to have containers run their applications as microservices, right? Like, we've got to do that. That's what all the internet says. Habitat works with containers in that in a couple of ways. We do all of our development of our packages currently in Docker containers because we know that we can use a minimal Docker container that has nothing else in it. We can use like an Alpine Linux and build our packages on that. And those packages, by the way, will work on CentOS or Ubuntu because they use all of Habitat's dependencies, not whatever the underlying OS's dependencies are. So we do clean room builds inside a Docker container. So that's one way we use it. And the other way is that you can, after you've built the package, so I did that build, I could then run hab package export Docker core/ruby/rails Ruby Rails sample, and then I would get a Docker container out of it. Right now we can export packages as Docker containers, but in the future we probably want to be able to do CoreOS's Rocket, EC2 AMIs, and that sort of thing. Those are like future things that we might be building at some point. Next question is, does Habitat work on Windows? No, sorry. But the good news is that we're going to work on porting Habitat to Windows. And we want the Windows user experience to be as easy and delightful and as intuitive as Windows admins would expect that to be. Because we love our Windows administrative brethren and sisters, and they don't necessarily have an easy time with the tools that they're given to do automation. And Microsoft is really coming around on this, and we're working with them to make this a really truly delightful experience. So it's I don't know what the roadmap terms of that are, but I know that it's something that we're going to work on very soon, and having Habitat work on Windows is a high priority for us. Yeah, like all kinds of good stuff will be coming out of that. Does Habitat work with the OS or distro packages? Nope, it doesn't use them. It doesn't care about them. It doesn't matter if you're using Ubuntu or CentOS because you're doing all of your builds in this clean environment that don't have any of that. So it doesn't need any of that. So I can take that Ruby Rails sample heart file that I just built on an OS X system that was running a Linux container, and I can take that package and install it on Ubuntu 16.04 or on Red Hat 7 or on Gen 2, and as long as I have a 64-bit kernel greater than 2.6.32, it will work because it's all using Habitat and Habitat's binaries in the way that it was built. So it gives us a lot of freedom to be able to move our applications to any kind of any other Linux platform that we want. maybe question, would it work on FreeBSD? Probably with a Linux compatibility layer of FreeBSD. Probably. I don't know, I haven't tested it. We also have a whole lot of core packages. So we have most all the dependencies you would need for common application runtime frameworks like Rails and Erlang and Python. We're working on PHP, we're working on Java. We have all these are in the core repository that the Habitat team maintains. The astute may wonder, didn't you just create a new distribution? I mean, sort of. But what we did is we created a way for people to be able to build and manage their applications no matter what their distribution is. Is it better than Hadoop? Of course it's better than Hadoop. All right. We have the Habitat zone on the opposite side of the building around the corner. Like, I don't know. I don't even know where it is from here. But it's over near room 404. So if you can't find it, just look for the Habitat banners and stuff. And unfortunately, you just missed Fletcher Nickel talking about Habitat internals. Sorry. And we'll also have Nathan Harvey talking about building the Habitat community over there.
I think I just lost. Then why can't you say from scratch by example? Not a Docker question, but what's still needed that you actually needed a base OS in the container?
Besides the base OS in the container, you need the hab binary, and when we use hab studio enter, it automatically installs what it needs to do that. So one of the things that we learned while we were building this is what Adam was talking about with having humane software. And in order to have humane software, you need to have software that behaves pretty much like you'd expect. And so there's a little bit of magic, but there's a whole lot of delight. We've worked really hard to make it easy to use, and it actually, once you start using it, it ends up being more simple than you thought it was going to be. You'd be like, okay, so how do I get all the things I'm going to need to install this? It's like, it gets all that for you. It handles it automatically.
So there's a question I have about upgradability of the packages afterwards. Right, we quite often end up deploying a package out, and then we have no control necessarily of when a customer is going to upgrade a package. How does Habitat handle that, or does it handle that, or is that just like left up to us to figure it out?
So yes, Habitat has the capability of automatically upgrading the packages. It can detect from the depot that the package that a new package version has been released and uploaded, and then automatically install it. It can also be configured to not do that, because maybe we don't want to roll out that new version quite yet. There are update strategies. We're working on fleshing out what all those update strategies might be. But the main things are that we have the capability to automatically upgrade, and we have the capability to not automatically upgrade. And doing like rolling kinds of things is still something that's kind of in the air about that.
For a complex, for example, a Python dependency chain, for example, we would need to pin many upstream Python pip modules. Is that possible in the plan? Can we set different sources? Do they all need to come from the, I guess, the depot?
So I don't know a lot about Python. So one of the things we do with Ruby, you have a gem file, and in that gem file you define your dependencies. I imagine Python has a similar thing, and then when you do a bundle, you get a gemfile.lock, and then you can commit that lock file to your version control system so that you can always get those specific dependencies, right? And I imagine Python has a similar thing, yeah. So you can always get you would always get those dependencies from doing the build. You'd have the build step that would install those for you inside of your app. Now, if you wanted, you could have you could package up all those various Python packages and make those available. But what I would probably recommend is to go the route where you vendor that all into your application so that it's all in lockstep, and that way we don't have like version sprawl of all these various Python packages out in the depot.
So, Josh, you just said to package up all of the dependencies, be it bundler or pip or what have you. So are Habitat containers or are they composable? Can I start at some sort of base layer with a set of things that I typically would use, or will I have to come from the clean room, as it were, every time?
I would recommend going from the clean room every time. Habitat doesn't do like a layering kind of thing like Docker does. It doesn't have that as a thing. When I was going through the deps files, the build deps, the deps, tdeps, those are all the versions of all the packages that it depends on. So it wouldn't be built up over like, you wouldn't have like multiple versions of OpenSSL as a dependency. You'd depend on whatever the latest one was, or if you needed a specific release, something like that. Does that answer your question? Okay.
And then I saw in the plan file that you exposed ports for the app. Would multiple hab installs need, I'm sorry, would they conflict in any possible way other than those ports if you were to, like we were talking about, attempt to compose different hab installs on the same machine?
Can you repeat the question?
So if you didn't hear the question, you expose ports, would you have possible conflicts of those ports between multiple different packages? Yeah, I mean, you could. No, because we isolate all the dependencies. So like every time you start up an EC2 instance or a VMware image or rack and stack a system that's going to run hab on bare metal, each of those would be their own isolated system, and they would have like whatever service that they're running would get its dependencies for that. Now, if you had multiple ports running, I mean, they're on different systems, they're on different IPs, right? So if you had multiple packages running on the same system, there's a way to do that with Habitat. It's called the director, and it can run, like you could run Postgres and Ruby app and put Nginx in front of it and run that all on one single system, and they wouldn't have any, assume they wouldn't have any conflicts because you'd expose them on different ports.